Okay, story time. C# has this cool attribute called CallerMemberName. It's magical and ugly at the same time because it's really special. When added to a method parameter, the compiler will actually replace the value of the parameter with a calling member name. Okay, that sounds really weird. So let's look at it in action. I'm gonna just call print more info and not pass any parameters at all. So theoretically, if that would be a normal method, the value of member name would be an empty string. However, if I run this, what I get is run, not an empty string. So what's happening here? Well, it's kind of magical. See, if I look at the implementation of CallerMemberName attribute, it's actually doing nothing. However, if I decompile my assembly, I will get a specific value passed to print more info run, which is the name of the method it was called from. It's important to note that this value is generated during the compile time. So it's kind of a poor man's source code generator. And what I personally like about this solution is that it has zero reflection or runtime overhead. Everything is happening in compile time. So you don't need like IL rewriting or Weaving or any third-party libraries to do this. But wait, I've got even more tasty stuff here. Just like CallerMemberName, there is also a CallerLineNumber and CallerFilePath. Line number is of an integer type, and just like CallerMemberName will be set by a compiler to a line number inside your source code, which call this method. FilePath, in addition to this, can also pass the path of the file where the call has occurred. I mean, this is crazy. Let me just call this method and see what happens. I will run print more info too, and what we've got is member name run. Just like before, we've got line number and we've got file path. This is awesome. I love it. These things are absolutely useful for something like logging and diagnostics, where you can log where an issue has occurred without any external magic. C# compiler already provides all the essential metadata. IObservable implementations can also use this approach without any runtime overhead. You can write your own feature flags. So, for instance, you can have some custom logic based on what method has called your feature, and so on and so on. But there is one more thing equally magical, and it's called CallerArgumentExpression. I love it. It's really cool. So, just like before, you declare it as an optional parameter with a default value of null. It has to be a nullable string, and then you pass the parameter name inside this method. In this case, it's a condition, which will be used to generate a string representation of an expression from outside of this method. Okay, that doesn't sound clear, but what happens is when I call validate and I pass parameter name, which is test, and then Boolean condition, and it can be anything, the compiler will take this Boolean condition, create a string representation of it, and pass it as a message parameter value. Okay, let's just run this. And what you can see is that our method did throw an exception, but look at the message of this exception. It says argument failed validation. We also have the parameter name test, but we have a message as well, which is set to expression 2 + 1 = 4. I mean, this is mind-blowing. But to better understand what's happening, let me just decompile this code. I'll also uncomment the previous method because I think we didn't look at it at all, and I'll open the code in ILSpy. Now, have a look. Validate receives the third parameter as a string, 2 + 1 = 4. This is generated by a compiler when the program actually compiles, not in a runtime. That's what's so cool about it. It's actually source generated. Also, have a look at the print more info2 method, which accepts 3 parameters source generated by a compiler. This is really, really cool. I'm blown away. That's it. Thanks for coming.